When working out panel inverter configurations on residential and small commercial, it's usually an exercise in trial and error. But what about the really big systems? For instance, 600 kilowatt, 1 megawatt, where you're using multiple inverters, different string configurations, and in some case, different panels. What then? Hello, spreadsheets. Hi, I'm Veli from Greenwood Solutions. We're talking large-scale commercial solar inverter panel configurations. Now, if you like what you see with this video and you want to see more of what we do, hit that subscription button. Let's get stuck into it. Now, with smaller commercial domestic solar systems, the ability to design the inverter string configurations for the PV component, it's fairly straightforward, and methodically you need to go through all the component details. You know, the inverter specs, the size, the number of maximum power point trackers, the number of inputs, and the max current acceptable for those inputs. Panel specs, the wattage of the panel, voltage, current. And then the full inverter specs and panel specs are matched. In this example, we're looking at 3 Fronius Eco 27 inverters. We're using 445 watt panels, and we want to design a system that takes into consideration the string configurations and just comes in under that 100 kilowatt limit. Now, the process of designing string lengths, etc. with small systems are trial and error. For example, Fronius 1, 18 times of 445 watt panels times 4 strings equals 33,040 watts. Inverter 2, we're using a similar configuration. 18 times 445 watts by 4 strings, 33,040 watts. And Fronius 3, 18, again the same configuration. And the total is 96.12 kilowatts. So we're not quite there yet. We're pretty close, but not quite there. So let's try another. Total is 97.9, but we can do a bit better. Here we go again. We're at 101.46 kilowatts. We've gone over. Hopefully this is the last one. $99.68 kilowatts, yes, finally. Hello, spreadsheets. To make the task easier, we'll need to take a spreadsheet approach that takes into account all the factors previously mentioned. And through the creative use of a few functions, this process can be automated to a degree. And the important thing is to get all the correct details of the components you're using. So we're looking at a larger system here on this particular case study using more than one inverter. And in some cases, projects may require 2x-PV options as well. So as well as the above factors, you have all the calculations required to optimize system design with the added factor of the physical reality of the roof in which you're installing the system, or the ground if it's a ground mount. So the VOC max with the buffer allows a little bit of leeway if you're uncertain about the actual lowest temperature of the site. I have used -10, and in most cases in Australia, that's going to cover every spot that you could possibly install a commercial solar system. We've established that there will be the possibility of a 2x-panel option, and the full details have been entered into the spreadsheet. Now for the inverters, on many big jobs due to various factors, multiple size inverters, usually of the same brand, thank you, can be used. In this case we are using 100 kilowatt and a 30 kilowatt inverter, and we now need to input into the spreadsheet the inverter details. And you can see, much like the panel option information, we've entered all the relevant details of the inverters. In this case, we're using 2 Hawaiis. I've said model number is test 1, test 2, but we've got 100 and a 30 multiple maximum power point trackers, as you can see. a really high max input voltage, interestingly enough, of 1500 volts, and the rest is, max current per maximum power point tracker, short circuit current, etc., etc. Really important to get this into the spreadsheet. Here's inverter details, and if you're looking, it's from column 1 to all the way across. You've got string number, inverter option number, the signage nomenclature, in other words, the signage that goes on the DC isolators connected to the various strings, inverter number, maximum power point number, and the string number. Now, as we are selecting inverter 1 as our first option, column 2 signifies this and acts as a trigger. Column 4 is the inverter number, in this case 1, as we are using multiple units. In other words, inverter 1 of maybe 3 or 4. Inverter 1 has 6 by maximum power point trackers and 2 by inputs per maximum power point tracker, as indicated in column 5 and column 6. So this particular inverter has effectively 12 inputs, so 6 trackers, 2 per tracker. Now, the signage is indicated in column 3, and this is automatically generated by a formula that can be dragged down that references inverter number, the maximum power point tracker number, and the string input number. So very important from a signage perspective. So now we're looking at panel details. The first column references the panel option, which populates the second column. The fourth and fifth columns do a basic calculation to determine the VOC max of the string and the wattage of the string. And hello, XlLOOKUP. To determine the VOC max with buffer of the panel and therefore of the string, I've used an XlLOOKUP function that asks a question if the number, and have a look at the arrow, is 1, then search the solar panel option details area. If the number is 2, same thing happens. These formulas can be copied to other cells to achieve the same results. Now we're looking at the total wattage of inverter and the DC to AC ratio. So for this inverter, we can see the wattage per string and total for the inverter. Also, we can set up some conditional formatting to warn us if the DC-AC ratio is exceeded. In the case above, you will see that the 30 kilowatt inverter, number 4, has exceeded the DC-AC ratio considerably, so we'll need to modify the number of strings or length of strings or the panel used or all. Using conditional formatting, in this case with DC-AC ratios, really helps the designer see if they've made a mistake with some of the string configurations. You really don't want to exceed that desired DC to AC ratio. I've used a white font with a red background, but you can use whatever. So to rectify this, we have changed the panel to a lower VOC max, have reduced the number of strings, and have increased the number of panels per string from 60.52 kilowatts now down to an acceptable 34.2 kilowatts for a 30 kilowatt inverter. All is good. Warning, the next slide has a lot of information. Spend the time, maybe stop the tape and have a jolly good look. So we have the following. Inverter 1, 100 kilowatt, total wattage of 128,160 watts. Inverter 2, we have 100 kilowatt, total wattage of 113,850 watts. Inverter 3 is a 30 kilowatt inverter with total wattage of 32,400 watts. And inverter 4, 30 kilowatts, again, total wattage of 32,400 watts. A grand total of 308.61 kilowatts, using 2 by different inverters, using 2 by different panels with different string configurations. Conclusion. Note, the inverters used have a VOC max of 1500 volt and a rated input voltage of 1080 volts. And triggers can be used with conditional formatting to show a cell color change if certain parameters are exceeded. We have barely touched what can be done, and in further presentations we'll look at more advanced techniques which can help the designer installer put together these large-scale systems more easily using a spreadsheet approach. Thanks so much for watching our presentation on inverter panel configurations for large commercial solar systems. I'm Veli from Greenwood Solutions. If you have any questions, any inquiries, any answers, please feel free to drop us a line. And if you like what you see and you want us to make more of these videos, please hit that subscription button. See you next time. You can make a spreadsheet for anything. I once tried to make one from our director's guitar skills, but there wasn't enough columns and rows.